So welcome to the video on complex numbers in trig form. To start, let's just remind ourselves what a complex number is made up of. We have a real component and an imaginary component. And we write that usually in the form of a plus bi. I'm going to say that that is equal to z. We're going to use the letter z to represent complex numbers, and you'll see why when we get into some other types of problems. So in this video, we're going to learn how writing a complex number in trig form is actually going to be more useful when we get to things like raising a complex number to a power. So in order to do that, we have to go from a plus bi form into trig form. And basically that's the same thing as saying polar form. So let me just draw a little picture here of what a complex number plane is made up of. You have the real axis and the imaginary axis. Right? So we have the number a plus bi, so that would mean you're going a in the real direction and b in the imaginary direction. Right? So that's where that number z would wind up on the complex plane. Now, we could also think of that in polar form. So if I just draw in that radius there, we could find that distance. So that distance would be the square root of a squared plus b squared. And we would be able to find what this angle is here by using some inverse trig. So let me just draw a new picture. Okay, so there's the same number, a plus bi. We know that we can find the length of that radius. I'm going to label that r, and the angle in here, theta. And then again, remind us that we know that the pieces here would be r cos theta and r sine theta. So when we have a complex number, we can write it in a plus bi form, or we could write it in trig form. So in this case, we would have r cos theta plus r sine theta I. Right, because we're still saying that this is the imaginary axis right here. So we could factor out that r, so then we write it as r times the quantity of cos theta, plus I sine theta. So we're going to use this trig form right here in order to do some more calculations. So let's try that. So we have 1 plus root 3i, that's in a plus bi form. Let's go into trig form. So I'm just going to draw a quick picture here. The real part is 1, the imaginary part is root 3. And we actually know that this radius is going to be 2. If you remember, this is a 1, root 3, 2 triangle. In other words, it's a 30, 60, 90 triangle, and that angle right there is 60 degrees. So I can say that this number is also the same as 2 cos pi over 3 plus I sine pi over 3. So that one is easy to do without a calculator. The second example, we're actually going to need a calculator because we're going to need some inverse trig. And you'll see why. So let's plot this. We're going to go -2 this direction and 1 in the imaginary direction. Okay, so the legs are 1 and 2, so that means our radius is going to be root 5. And I'm not sure what this angle is, right? It's not a 30, 60, 90 or a 45, 45, 90. So let's set up some inverse trig. I'm going to use tan inverse of 1 over -2. And I'm going to use some Wolfram alpha here. And the angle I get is negative 26.57 degrees. So remember, that's going to put you in the fourth quadrant right here. We want to be in the second quadrant. So this angle in here, this must be positive 26.57. I need this angle in here. So we'll just do 180 minus the 26.57. So this angle in here is going to be 153.43 degrees. So my answer in trig form would be root 5 times the quantity cosine 153.43 degrees. And we could also put that in radians if we wanted to. I just stuck with degrees this time. I sine 153.43 degrees. And please don't forget the degree symbol, because it makes a difference. We need to know, is this in degrees or is it in radians? Okay, so we were able to go from a plus bi form into trig form pretty easily. Now let's see what we can do once we're in trig form. Let's think about multiplying and dividing when we're in trig form. So here I have two numbers, both in trig form. Turns out that when you multiply them, you're just going to multiply their radii and add their two angles. So my new radius is r1 times r2. And then once we're in trig form, we're going to do cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. And you might be wondering where that came from. Well, I'm going to leave that to you to prove. If you actually did the multiplication out, you could rearrange things to look like this. And the same thing with division. I'm going to leave the proof to you, but you might have already guessed that the radii are going to be divided. And instead of adding the angles, we're going to subtract them. So we have cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. So let's do some examples with that. So here we have two complex numbers. Let's try multiplying them when they're in a plus bi form, just to kind of remind ourselves how to do it that way. So I'm just going to do FOIL. So I get negative 1 plus 1i minus root 3i plus root 3i squared. Okay, remember that I squared is really negative 1. So that's going to change this into negative 1 plus 1i minus root 3i minus root 3. I'm going to combine my real term, so negative 1 minus root 3. That's my real term. And let's combine the imaginary terms here. Plus 1 minus root 3i. Okay, so that's in a plus bi form. Now let's try it in trig form. So in order to use the trig form, we're going to have to put each of these numbers into trig form. The 1 plus 3i, root 3i, we actually did already. We did that previously in the video. So we already know that the first number is 2 cosine pi over 3 plus I sine pi over 3. But this negative 1 plus I, we're going to need to put that in trig form. Let me just make some space here. Draw a little picture. Negative 1 plus 1i. Looks like we have a 45, 45, 90 triangle, so our radius is root 2. This angle in here is 45. In radians, that's 3 pi over 4. So we're going to be multiplying with root 2 cosine 3 pi over 4 plus I sine 3 pi over 4. Okay, so the rule says we're going to multiply the radii, so now we get 2 root 2, and we're going to add the angles. So pi over 3 plus 3 pi over 4 on both the sine and the cosine angles. So now let's see, I'll just do my work over here again. Pi over 3 plus 3 pi over 4. Let's make a common denominator of 12. So that's 4 pi over 12. This is going to be 9 pi over 12. We add them together, we get 13 pi over 12. So there's our answer in trig form. There's our answer in a plus bi form. You might think to yourself, well, a plus bi form actually seemed easier. And I agree with you. On this problem, it probably was easier. But remember, we're doing this for a reason. Once we get into multiplying a whole lot of things, I think we're going to realize that trig form's better. And you're going to see that in class. Let's do one more example with division before we're done with the video. So let's use the exact same numbers as before. So going into trig form, we already know that this is 2 cosine pi over 3 plus I sine pi over 3. And this one was root 2 cosine of 3 pi over 4 plus I sine 3 pi over 4. And the rule here said that we're going to divide the radii. So 2 over root 2, we could rationalize that if we wanted to, right? So 2 over root 2, that's fine for right now, but just remember we could rationalize that. Is going to be our new radius, and we're going to subtract those angles. So pi over 3 minus 3 pi over 4 is our new angle. So let's do that subtraction there. And we get negative 5 pi over 12. And that's fine to leave it like that right now. There's no need to make it a positive angle. If the directions said that you needed a positive angle, obviously you should change that. What would that be? 21 pi over 12. You could actually reduce that as well. But there's nothing wrong with leaving this. We don't want to do anything else with this for right now. We're just practicing that new rule. Okay, so there's some practice problems in the book for you to try and just get some basics down. Good luck with those.